Single Layer Perceptron, SLP, versus Multi Layer Perceptron, MLP. What is Single Layer Perceptron? A Single Layer Perceptron, SLP, is the most basic type of artificial neural network, ANN, consisting of just one layer of output neurons. Training was performed using the Perceptron learning algorithm, with weights adjusted, depending on differences between expected and actual outputs. What is Multi-Layer Perceptron, MLP? The Multi-Layer Perceptron, MLP, is a type of feed-forward artificial neural network that consists of multiple layers of interconnected nodes, or neurons. Unlike its predecessors, such as the Perceptron, MLP consists of an input, one, or more hidden layers, and output. Each layer consists of multiple neurons, and the connections between them are weighted, allowing the model to learn complicated patterns from input data. Difference between Single-Layer Perceptron, SLP, and Multi-Layer Perceptron, MLP. Development history. SLP is the simplest form of artificial neural network, ANN, and the Perceptron model was introduced by Frank Rosenblatt in the 1940s. While MLP's development became significant in the 1980s, with the introduction of the backpropagation algorithm, which enabled efficient training and led to the rise of deeper neural networks. Architecture. Single-Layer Perceptron, SLP, has one layer of output neurons, directly connected to input features. It has no hidden layers. Whereas, Multi-Layer Perceptron, MLP, consists of an input layer, one, or more hidden layers, and an output layer. Each layer comprises multiple neurons, and connections between layers are weighted. Problem solvability, or linear separability. SLP can only handle linearly separable patterns, limiting its classification capabilities to data separated by a straight line or hyperplane. On the other hand, MLP can learn complex patterns and relationships in data due to its multiple hidden layers, allowing it to capture nonlinearities that SLPs cannot handle. Activation function. SLP typically uses a step function, outputting 1, if the weighted sum of inputs exceeds a threshold, 0 otherwise. While MLP can use a variety of nonlinear activation functions in hidden layers, such as sigmoid, ReLU, or tan. Learning algorithm, or training. SLP is trained using the Perceptron learning algorithm, adjusting weights based on errors between predicted and actual outputs. It does not include backpropagation. Whereas, MLP is trained using backpropagation and gradient descent. The backpropagation algorithm was proposed by researchers such as Rumelhart, Hinton, and Williams. Output. SLP produces binary output, 0 or 1. On the other hand, MLP produces continuous output, for regression, or multi-class output, for classification. Applications. SLP is used in binary classification, pattern recognition, and linear regression tasks. Whereas, MLP is applied to complex tasks, including classification, regression, and image recognition. Complexity. SLP is simple and limited, while MLP is complex and powerful. Feature representation. SLP lacks the ability to extract hierarchical features. On the other hand, MLP can automatically learn hierarchical representations of features through multiple layers, facilitating better feature extraction and representation learning. Universal approximator capability. SLP cannot approximate complex functions beyond linearity. While MLP with a single hidden layer containing many neurons can approximate any continuous function, making it more versatile than SLPs for a wide range of tasks. Performance. SLP is limited in performance due to its inability to handle nonlinear data. Whereas, MLPs often achieve higher accuracy and better performance on various tasks, especially for datasets with nonlinear relationships between input features and target variables.